Hello, this is Ms. Ahmed, and this lesson will show you how to evaluate exponential expressions. In our previous lesson, we wrote exponential expressions in expanded form. For example, 5 to the third power we wrote as 5 times 5 times 5. If you want to evaluate this, you could type in your calculator 5 times 5 and then multiply the answer times 5 again. But when you have a larger exponent and also a larger base, it's easier to use the calculator a different way. So that's what we're going to do today, evaluate exponential expressions to find their equivalent standard form. Most calculators have a little button that looks kind of like a triangle without a base. So if you have a handheld calculator, you want to look for that first. If you have that button, then you're going to enter the base, and then the little button, which is kind of like a triangle pointing up, and then the exponent. When you enter the exponent, the screen of your calculator should change, and you will see the base and the exponent written in exponential form. If you press equals or enter, you'll get the standard form equivalent. Our assignments, we use Delta Math. They have a slightly different way of using the keys. You enter the base first, then you press the key that says a to the b power, and then you type the base. When you push enter, then you should see the base and the exponent written in exponential form. And after equals or enter, you will see your answer in standard form. So try that with these examples of exponential expressions. 4 to the 7th power, 6 to the 8th power, and 9 to the 12th power. You probably noticed as the numbers and the exponents grow larger, the answers in standard form also get larger. So 4 to the 7th power is equivalent to 16,384. 6 to the 8th power is equivalent to 1,679,616. And 9 to the 12th power is such a big number that most calculators do not have enough places on their screen to show all the digits. So you might see something that looks like this, 2.8242953 E11. Now that doesn't mean that 9 to the 12th power is 2.82 something. Obviously it is a very big number. In fact, it's a number that has 11 digits after the 2, and there's not enough room to show them all on your calculator screen. So what that E11 means is that the value of 9 to the 12th power is 2.8242953 times 10 to the 11th power, meaning there are 11 places after the 2, 11 digits, and I'm not quite sure what comes after the 3, but it is a very big number. Remember, we learned that if you have a negative base, you must put it in parentheses, and this is true for the calculator as well as when you're writing it for a teacher. Also, fractions should be in a parentheses before you raise them to a power. So try evaluating these with your calculator to see what -4 to the 7th power equals, 2/5 to the 3rd power, and 99 to the 0 power. If you entered it correctly, you should find that -4 raised to the 7th power equals -16,384. And we know it should be negative because any negative base raised to an odd power is negative. 2/5 cubed may be written in two ways in standard form, depending on your calculator. You may see 8 divided by 125, or you may see its decimal equivalent, 0.064, and both are correct. And 99 to the 0 power equals 1, because any number to the 0 power equals 1. To evaluate longer expressions with more operations than just exponents, you need to use the order of operations. In elementary school, you probably learned, please excuse my Dear Aunt Sally, to help you remember PEMDAS. Parentheses, exponents, multiplication and division, addition and subtraction. In high school, you might find it more useful to use the acronym GEMS. G is for grouping symbols, which includes not just parentheses, but also brackets, absolute value bars, radical signs, and a fraction bar. The E is still for exponents, M is for multiply and divide, left to right, and S is for subtract and add, left to right. So let's look at a few examples to see how we will use these. If you have a long expression like 3 times the sum of 3 plus 7 minus 4 squared divided by 2, the first thing you're going to do is your grouping symbol, parentheses. And you'll get 3 plus 7 equals 10. So you have 3 times 10 minus 4 squared divided by 2. Next you'll do your exponents. And 4 to the second power is 16. Now this expression has multiplication and division. I'm going to do them left to right. 3 times 10 is 30. 16 divided by 2 is 8. And your last step will be addition, or in this case, subtraction. So that long expression simplifies to 22. Here's a different example. 8 times 7 plus 7 times 2 to the 4th power plus 3. We're going to use GEMS. The first letter is G, but in this case there are no grouping symbols. Second letter is E for exponents, so 2 squared we're going to rewrite as 4. M stands for multiply and divide. There's no division here, but there's 2 multiplications, 8 times 7 and 7 times 4. And the last step, subtract and add. There's no subtraction here, but we can add 56 plus 28 makes 84, and 84 plus 3 makes 87. Our last example, we have the difference of 5 squared and 16 over 3 squared. So here we have 2 grouping symbols. We have the parentheses and the fraction bar. With a fraction bar, you're going to treat the numerator and the denominator as separate parts. Simplify them first before you divide. So in the parentheses, we're going to follow GEMS just for that expression inside the parentheses. So we'll do the exponents first, and 5 squared equals 25. There's no multiplication or division inside the parentheses, so we can just subtract. 25 minus 16 is 9. We simplify the numerator. Now we're going to look at the denominator. It has exponents, so 3 squared is 9. Our last step is to divide, because the fraction bar tells us divide. 9 divided by 9 is 1. In summary, exponential expressions show repeated multiplication, and we can use the calculator so that we don't have to keep typing in the multiplication. We use the little hat symbol or a key that says a to the b or x to the y on a calculator to find the standard form. If we have a longer expression with more operations, we must follow the order of operations to evaluate. And as you practice, you'll become more familiar with these steps and with exponential expressions.